Now let us practice L'Hopital's rule by a few examples. Consider the limit fraction e to x minus e to minus x divided by sine of x for x converting to 0. This goes to 1. This goes to 1 as well. And 1 minus 1 goes to 0. If x goes to 0, then sine of x goes to 0 as well. And we have an indeterminate expression 0 divided by 0, so we can try L'Hopital's rule. So we have limit for x going to 0. Derivative of e to x is e to x. Derivative of e to minus x is minus e to minus x. Minus minus gives plus. So we have plus e to minus x. And the derivative of sine is cosine. But this function is fortunately continuous at 0, so the limit exists and is equal to the function value. 1 plus 1 is 2 divided by 1 is 2. What about the other expression? If x goes to by half, then cosine goes to 0, and cosine square goes to 0 as well. And if x goes to by half, then when subtracting by half, this difference goes to 0 as well. So we can try L'Hopital's rule, and we have limit for x going to by half. And now the derivative of cosine square is 2 times cosine times the derivative of the inner function. The inner function is cosine, and the derivative of cosine is minus sine. So minus sine of x. And the derivative of x minus by half is 1. Well, and this is a continuous function at by half, so the function exists and is equal to the function value. Cosine pi half is 1. Sine pi half is 1. Cosine pi half is 0, so the result is 0. And what about the next limit? X goes to by half, this is the same. We have similar functions, but this time the square is not here but here. But from the same reasons, this goes to 0, and this goes to 0, so we can try L'Hopital's rule. Limit for x approaching by half, fraction. Derivative of cosine alone is minus sine alone. And derivative of square is 2 times the bracket x minus by half. If x goes to by half, then sine goes to 1, and minus sine goes to minus 1. But now, this difference goes to 0. So we have minus 1 divided by 0. This is not for L'Hopital's rule anymore. Now we must consider the single-sided limits. Namely, if x goes to pi half from the right, then x is slightly more than pi half, and this goes to 0 from the right. Note that by adding this plus, we have changed the definition of the problem. This is a different case than it was before. Now we compute the one-sided limit, which is a different case, different problem. But we will need this result for the original problem. But negative 1 divided by a small positive value goes to minus infinity. So this is the one-sided limit. If x goes to pi half from the left, then this is again minus 1, but this goes to 0 from the left. And negative divided by negative is positive. And 1 divided by very small is very large, so this times this second one-sided limit is plus infinitive. And because the two one-sided limits do not agree, are not equal, the both-sided limit does not exist. So let me copy this once again. Limit for x approaching pi half as a two-sided limit of this expression cosine of x divided by x minus pi half squared does not exist. Because we have computed the two single-sided limits using the L'Hopital's rule, and the result was two different results. So the both-sided limit does not exist.